All right, cool. Let's get started. Well, hello everyone. Yes, so Thessaloniki. Um, Thank you. My name is Abdel. I'm a developer advocate at Google. Okay, good. I'm going to be talking about service mesh today. By show of hands, how many people? By show of hands, how many people heard of service mesh before? How many people actually use it in production today? Few of you. How many people here have used Kubernetes before? Okay, a big group. Good, good. All right. So let's see. Let's see if this makes sense. I have 3 goals with this session. Explain what the buzzword service mesh means. Give you some basic understanding of containers, Kubernetes, and Istio. The reason I choose Istio is because A, it's a Google project, and I work for Google, and B, it's because it's the most mature open source service mesh today on the market. There are other ones like Linkerd, there is Cilium Mesh, there is a bunch of other ones, but Istio was the first to actually introduce the concept of service mesh, and it's by far the most mature. And when I mean the most mature, it's because it have existed for a very long time. It has a very strong community, and today it actually was donated to the Cloud Native Compute Foundation, the CNCF. So it's basically just sits within the same organization that owns Kubernetes, and like hopefully give you some pointers about how you can make your life easier with service mesh. So I'm going to go through the regular stuff that you have heard before. We used to do monoliths. Monoliths were cool until they were not, and then we decided, let's do this thing, which is we take a monolith, we keep running it, and then we stick an API around it, and we call that a modern app. Maybe the oldest among you will remember XMLRPC. I have done XMLRPC before. It was painful. And then, like every developer ever said, let's rewrite everything from scratch, because that's what developers love to do, right? So we came up with this thing called microservices, and it was an excuse to rewrite everything from scratch. Microservices have some good things around them, and they have some bad things around them. Some of the good things is they are easy to release, they are easy to reiterate about on. It's easy to release features when you're working on microservices, not like a monolith. If you have worked on monolith apps, you know that you probably had 1 or 2 releases per year. And then containers showed up in 2014. And containers really, what they did is they just made microservices even easier. The concept of containers was democratized with Docker when it was released in 2013, sorry, not 14. But the idea of how a container actually runs is not new. There is nothing magical around Docker. It's an abstraction layer that makes building and running containers easier for everyone without having to understand the underlying mechanisms. But those underlying mechanisms have existed in the Linux kernel for a very long time. If you have done any Linux system administration, you remember things like chroot and cgroups and namespaces and stuff like that. Basically, what Docker did is just took all these things together and make them easier with the command line and the text file, which is the Docker file, right? But obviously, running containers on a very small scale is not the same as running containers at a very big scale in a distributed way. At a small scale, running 1 or 2 containers on your laptop is easy. You just write a Docker compose file, Docker up, and then you're good to go. Running containers for production in a distributed system comes with a lot of problems. And these are not problems inherent to containers. They are problems inherent to distributed systems in general. I'm not going to go through the list. I think it's boring. And that's why Kubernetes was released in 2014. The purpose of Kubernetes was to solve containers D2 problems. The whole point of Kubernetes was, let's take an infrastructure, which is composed of small virtual machines or physical machines or Raspberry Pis, it doesn't matter. And then we will run something on top of it, and then we will give you an API that allows you to interact with the hardware without having to SSH, without having to write Chef or Puppet scripts, without having to write bash scripts. So it's really like, my favorite way of describing Kubernetes, it's an operating system for cloud. It's the same way an operating system allows you to use the hardware, Kubernetes allows you to use the cloud with an API, essentially. And there are two main things that a lot of times people don't talk about when it comes to Kubernetes. Like the most easy way to understand Kubernetes is the architecture, which is the control plane, data plane kind of architecture. So you have like a bunch of nodes that you can consider the control plane, the API, the brain of the system if you want. And then you have the nodes, that's where your workloads run. But Kubernetes has this very, very powerful controller system, which is a concept. And the way the controller system works is that it has this like loop which is the observe, compare, and act loop. I take a very simple example. If you have a Kubernetes cluster running and you try to deploy an app, if you have done this before, you are expressing what you want to do in a declarative manner. You write a YAML file, and YAML is not a programming language, it's just a declarative configuration language. So you write a YAML file, and what you're really saying in the YAML file is, I want this to happen. I want to run one container. I want it to listen on this port. I want it to have these labels. I don't care how that happens. That's not my problem. You send that to Kubernetes. That state that you want to declare gets stored somewhere. And somewhere in Kubernetes system, there is a controller that will monitor and watch for when that state is stored and then act on it, as in spin up the thing you needed to spin. And this is extremely important to understand in Kubernetes world, because that's what makes the API actually even extendable. Like, you can take Kubernetes as a base system and build your own stuff on top of it, right? You can build your own thing that spins up your own application. It doesn't have to be the built-in API that Kubernetes supports. On a very high level, Kubernetes has a very simple architecture. You as a user, you use something like an API or a command line to interact with what we call the control plane. In the control plane, there are a couple main components. I'm going to talk about the two main ones, which are the API server and etcd. So etcd is a distributed key value database. That's where the state gets stored. That's where stuff gets stored. That's where you store the configuration that you want Kubernetes to execute on. And the API server is just a REST-based stateless application, which basically talks to etcd and talks to all the other components. On the green side, that's where the worker node, we call them. So the worker node is where your actual container will run. It has a bunch of components. The two main ones are the kubelet and the container runtime. So the kubelet is the component that talks to the control plane and receives orders and reports the status of the node back to the control plane. And the runtime is the actual thing that runs the containers. So a very, very dumb way to explain Kubernetes, or explain Kubernetes like I'm 5 years old, is when you are on your laptop, you do Docker run, and your Docker command line will talk to the Docker daemon to spin up a container, right? That's typically how you would spin up a container on a VM or on your laptop. In Kubernetes world, you send an order to the API server, and the API server, through a very complex mechanism, will execute the Docker run for you at some point, because that's what basically gets executed to spin up the container. You just don't do it yourself. You tell a control plane to do that for you. But of course, believe it or not, Kubernetes doesn't solve all your problems. And that's what a lot of people realize after managing Kubernetes for a while, and then they go express their opinions on Reddit and Twitter, right? Let's take a very simple example. Let's assume you have two services. And by two services here, I don't necessarily mean a service in any connotation. Two apps, app A and app B. If those apps run and talk to each other on any protocol, if tomorrow your security team comes and say, we want to add TLS between them, or MTLS particularly. So for those of you who doesn't know MTLS what it is, imagine TLS but done both ways, right? In TLS world, the server has certificates. The client verifies the identity of the server through the certificates and uses the public key to encrypt the traffic. In MTLS world, this operation happens both ways. So the client and the server has a certificate. That's why we call it mutual TLS. So if you want to add mutual TLS, what it means literally for you is that you have to upload certificates on both ends. So application A has to have its own certificates, and application B has to have its own certificates. And if you're a developer, you will have to build into the app the TLS handshake. So you'll have to build the logic that exchanges certificates between the apps and then encrypt the traffic, right? Doing this between two applications is easy. Doing it between a lot of applications is not. So if you have multiple, like hundreds and hundreds of containers running somewhere, and you want to do MTLS, you can't do that manually. Well, you can, but you're going to spend a lot of time fixing it. So this idea of having a control plane that does this for us, having something central that issues the certificates, rotates them, distributes them, and take care of certificate management is also not new, right? If you have used Kubernetes, you probably have used Cert Manager. So Cert Manager really literally was designed to do this. And since we have this control plane, we can also make it do other things. We can make it collect telemetry. We can make it enforce policies. We can make it do routing. We can make it do a bunch of other things. And so this concept of building network intelligence into applications is not new. It existed for a very long time, and typically people would use libraries. I can give you a very simple example. If you're a Java developer and you just want to implement retries in a function, you can just import a library and annotate your function and then your function will or the library will re-implement these retries for you, so you don't have to do it yourself in the logic of the app, right? And those usually we used to call them proxy libraries. The issue with proxy libraries, obviously, is that A, you have to maintain them, B, you have to build them into your app, and C, this is the most important thing, is that if you work in an organization which is polyglot, which uses multiple programming language, well, you will have the same exact library in multiple programming languages, and you will have to maintain all of them. So the idea of service mesh, or how it was created, was the thinking was, why don't we take all these network functionalities and take them out of the app? So instead of the app doing network functionalities, we will do them outside of the app. And outside of the app typically means a proxy, right? My favorite quote in the world, which I created, so this is like a self-proclaimed quote, is there is only two kind of networks in the world. If it's not a proxy, it's a VPN. So like in networking, there is two things. There is VPNs and proxies. If it's not a proxy, it's a VPN. If it's not a VPN, it's a proxy. So the whole idea here is we take a proxy, which is a process, an app, that will run, and it will sit between the applications, and it will implement all these functionalities. In Kubernetes world, we call this proxy a sidecar. So why do we call it a sidecar? Kubernetes itself does not understand the concept of a container. The minimum deployable unit in Kubernetes is what we call a pod. And the pod is technically just a container that contains other containers inside, right? So you never deploy containers in Kubernetes, you deploy pods. And typically your pod will contain one container. But it can have more. And so by kind of like collective agreements, the community agreed that this extra container you run inside the pod, we will just call it sidecar. It's not any special type of container. Kubernetes doesn't even care that it's sidecar. It doesn't even call it sidecar. As far as Kubernetes is concerned, it's just two containers inside the pod. But just the convention, the word that we use collectively to decide what that thing is sidecar. And it's coming from this, in racing, you have like an extra little place on the side. This is an example where in a race with a sidecar, the objective of the person sitting on the sidecar is to make the turn of the biker tighter. So it's still the biker doing most of the work. The sidecar is just helping the biker execute what they need to execute. In Kubernetes world, a sidecar is not the main application. The main application is the container that you deploy. The sidecar is just there to implement extra features. And so typically you would deploy a sidecar if you have like a login agent, which collects logs from your application and push them somewhere, or a metrics agent, or something like that. So in Kubernetes world, for those of you who have used Kubernetes before, you know that in order to deploy networking, you deploy something called a service. So this is an example where I have multiple pods running the shopping application, and then I have multiple pods running the payments application, right? And so if I want the shopping app to talk to the payments app, I have to create something in between, and that something is called a service with capital S. So the service gives me a fixed IP, which is usually called a virtual IP, and that virtual IP, and also gives me a DNS entry, and that virtual IP will be used by the shopping cart to route traffic to the payments system. That IP is always fixed and doesn't change. And the reason services exist in Kubernetes is because in Kubernetes world, pods does not have fixed IPs. You cannot assign a fixed IP to a pod. A pod gets its IP from whatever node it runs on, and if the pod dies and gets rescheduled on a different node, it will get a different IP. So you cannot rely on the IP address of the pod. So they created another object which basically tracks the pods and route traffic to the pods regardless of where they are. Once you introduce a service mesh, you introduce an extra component. So what you do is you take each pod, and then you run inside the pod the application itself, and then next to it, you run the sidecar, right? And that sidecar is responsible for a lot of things, which we're going to talk about later, but mostly it's responsible for making pod-to-pod communication happen. And this is one of the reasons, this is the mesh part of service mesh, right? Because in traditional Kubernetes networking, you don't have a mesh. That little virtual IP acts like a load balancer. All traffic goes to the virtual IP, and then it gets distributed to whatever is behind it. In service mesh world, there is no load balancer in the middle. Every single sidecar knows where all the other sidecars are. And so communication happens from sidecar to all the sidecars. That's why we call it a mesh, right? And that's essentially half of the architecture of Istio. By the way, this is not specific to Istio. Like 99% of service meshes that exist today on the market works the same way. It's the same concept. There is a very valid reason or very simple reason why they are all similar. It's because they all run on Kubernetes, and Kubernetes has a fixed architecture. So all the service mesh tools follow the same architecture. So in Istio world, you have a control plane, which is called Istio-D. It's just a single component, completely stateless. Then you have the proxies or the sidecars, and the sidecars are actually running an open source proxy called Envoy. So Envoy is an open source proxy that was created by Lyft. Somebody at Lyft created that sidecar. It's a C++ based proxy. It's written in C++, so it's very, very lightweight. And what makes it very, very different compared to all the other proxies that you might have heard about, like HA proxy and Nginx and all the other proxies, is that it has an API. It doesn't have configuration files. So to configure Envoy, you don't write a configuration file like you would do for HA proxy. You actually use a gRPC API, and then you send API calls to the proxy to make the proxy alter its behavior, right? And so in the case of Istio, the control plane basically talks the Envoy API. It knows how to configure Envoy through the API. So you as a user, you send your configuration. Again, remember Kubernetes intent, you express intent in the form of a YAML. You write a YAML file that tells the control plane of Istio what you're trying to do. And then the control plane of Istio takes that configuration and converts it into calls to the Envoy API. I'm going to show you an example later. Then Istio has those extra components called ingress gateways and egress gateways. Without going too much into details, let me give you a little bit of terminology so you understand. In networking world, traffic between two components inside the same system is called east-west traffic, right? The other type of traffic in networking world is north-south. So if you're talking to somebody who is a network engineer and they say north-south, it means traffic coming from outside to inside the system or from inside the system to outside the system. This is typically what we refer to as ingress-egress, right? So ingress is traffic going in and egress is traffic going out. Communication between two components inside the same system is called east-west. So Envoy does east-west because that's basically communication between your microservices. Then in order to add north-south, they added two extra components, one called the ingress gateway and one called the egress gateway. Those are still Envoy proxies running standalone. They don't run next to anything else. They just stand alone. And the ingress gateway basically receives traffic from outside. And then the egress gateway sits between traffic coming from inside the microservice toward the external world. And they implement a bunch of extra features. So you can enforce policies. You can, to give you a very simple example, you can, for example, deploy an ingress gateway and configure it to only accept TLS 1.2. If you don't know, TLS has 3 versions right now, 1.1, 1.2, 1.3. And TLS 1.1 is, generally speaking, considered not secure. So if you want to enforce such a way that the clients can only talk to you through TLS 1.2 plus or 1.2 and higher, then you can configure it on the ingress gateway. Then you remember that mutual TLS thing we talked about earlier? That mutual TLS basically add in certificates to all your microservices through manually and how difficult it is. Well, now with a service mesh like Istio, we can do that. So inside Istio-D, which is the control plane, there is actually a certificate authority. And that certificate authority can be used to issue certificates, distribute them, and rotate them automatically. You just have to configure like a very simple configuration, and all that certificate stuff happens behind the scene, and you don't even have to care about it. So why Envoy? So yeah, Envoy was created by this guy called Matt Klein, who works at Lyft. I think he still works there. Lyft had a problem. They needed a proxy, and they basically created their own. It uses gRPC for its configuration, as I talked about. And it has like, it supports hot restarts. So if you reconfigure Envoy, you don't have to actually restart it. It will pick up its new configuration and start using it, compared to like traditional proxies like HA proxy or whatever. And it does like a bunch of other things. I'm not going to go into details. So let's look to an example. No, I'm way ahead of time. OK, so let me show you a very simple, very dumb example here. I have a Kubernetes cluster here. It's running a bunch of services. I'm going to show you the services. So I have multiple services. I have one called details. I have one called product page. I have a rating service, and then I have 3 review services, version 1, version 2, version 3. And you can see in the column that says ready, I have 2 out of 2, right? Because inside each pod, I have 2 containers. So that's basically Kubernetes telling me that each of those pods have 2 containers inside. Let me show you how the app itself looks like. It's just a very simple, like, kind of book catalog page thingy. So this page is rendered from the product page service. Then the reviews, which are the little stars, are coming from the review service, which you see here. That's where I have 3 versions, right? And then I have, if I log in, I can see the rating, but I'm not going to do that for now. But let's look into a very simple example. So let's see something. Let's start with something simple. If I refresh the page a few times, hopefully, hold on, then maybe. Yeah, if I refresh the page, you will see that those review stars, they alternate between red, nothing, and black, right? And then you see in the bottom, it says review served by, and I have which pod is serving me those reviews. So the red ones are V3, the black ones are V2, and the transparent ones are V1, right? Why do I have 3 pods? This is just a very simple example to show how you would typically do canary deployment, right? You have a service which is already running, you're introducing a new one, you would just introduce version 2 of whatever exists, runs already. And ideally what you want to do is you want to slowly shift traffic toward the new version to see if the new version works properly or not. So this is the example we have. We have review version 1, review version 2, review version 3. Now, in Kubernetes world, these things are wired together somehow. I'm not going to go into the details. But Kubernetes inherently, or by default, cannot do canary, right? Or cannot do A/B testing, it cannot do green, blue, blue, green, it cannot do any of this stuff. The only way it works is that when the product page calls the review service, it will hit one of the 3 versions that exist. So you have no control over which one gets what amount of traffic, right? But what I can do with something like a service mesh, because again, remember, just gonna find an example here. Here is a good example. Because I have those little purple thingies, which are the proxies, running next to each of my services, if I introduce a new version of the service, this is an example where I have service B version 1 and I'm introducing service B version 2, I can configure the mesh. Ignore the text, you don't have to worry about that. You can configure it to tell the proxy on the service A side, I want to route 95% of the traffic to V1, and I want 5% of the traffic to go to V2. And because the proxies are in the middle of where the traffic goes in and out, the proxy is able to route the exact amount of traffic you need. So it can literally count requests. If you tell it 5%, it means 5 requests out of 100. So for each 100 requests, it will make sure that 5 requests goes to the new version. So in my example here, as of now, I have just, I'm not using the service, the mesh. I have it installed, but I'm not using it. So as I am refreshing, I get like random versions. Now let's say I am very confident with my version 3. Version 3 is the one I want to, or let's take another example. Let's say I want to only do version 2 and version 3. So I want to only see the black ones and the red ones. What I can do is I can write a configuration like this. Again, without going too much into the details, but I can just write the configuration, and the configuration will define 2 destinations, reviews version 2 and reviews version 3, and each of them has a weight of 50. So now what I'm saying is I am sending 50% of the traffic to version 2, 50% of traffic to version 3. So let's go ahead and apply this configuration. I think it's this, and then it's virtual service networking, virtual service reviews V2, V3, boom. All right, so now I push the configuration to say whenever the product page is trying to call the review service, you will split the traffic equally between version 1 and version 2. So now if I refresh, I will get only the black and the red one, right? And so I will never see the V1 again because I don't have it. And if I am confident with my configuration and I receive the OK from my marketing team who says, OK, version 3 looks good, let's go red, I'll just do this. And I will basically route traffic, all the traffic to the red version, right? What did I do? I just did a canary deployment, essentially, right? I introduced a new version of a service, and then I used a networking layer component to split traffic initially equally between two versions, and then at some point I shifted traffic fully to the one I want. Without writing any code, without doing anything, basically. Like, one of my favorite examples of explaining how service mesh works, and I'm not sure how young or how old you are in the room. So let's try this and see if you will get it. Before mobile phones and internet, when you used to use your landline, your fixed phone, to call somebody, somewhere in a distribution center, there was people sitting there and like physically wiring two phones together, right? Like they would receive the call, they will, based on your destination, connect a physical cable to a plug to connect two different houses. And the next time, the same house that made call number 1 needs to call house number 3 or 2, they will just rewire that house. This is the same exact concept. You are building into the network layer of your application intelligence that allows you to shift traffic immediately without doing anything to the app. I did not restart the app. I did not redeploy it. I did not do anything. I just pushed a simple configuration, and I switched from one version of the application to a second version of the application. Make sense? OK. So that's service mesh. You can do a lot of things, right? So you can do traffic splitting, which we just saw. You can do, let me show you another one, which I'm not going to demonstrate, but I'm just going to show it. You can actually do header-based mapping. Let's see what it is, hold on. I have to go to documentation. Yeah, example like this. Hold on. That's not the example I want. Where is the header? Where is the header? Ah, come on. Request routing and yeah, here is an example. So I can do something like this. I can basically add a configuration that says if I have a header called end user and the value is JSON, then I can route it to version 2, otherwise route everything to version 1, right? So this is, if you would have to do this yourself, you would have to deploy a proxy yourself. Typically, you would do this on the requests coming from the internet. If you're, for example, you deploy a new version of the app, but you want only your developers to be able to talk to it. So you have to add a header to your requests to talk to this new unreleased feature or whatever. So you'd have to deploy your own proxy and do all that stuff yourself. Or maybe even worse, you will have to do it in the app, which you probably don't want to. And then you can do quite a lot of interesting things, like fault injection. So this is virtually injection of faults into a service. And this is an example where I define two versions of the same service. So service B version 1, service B version 2. And then I split traffic 95.5%, but then I am injecting a fault every 0.1% of the traffic. I add a 5 seconds delay, and then every 0.1% of the traffic, I return a 400 HTTP request, right? Again, everything is done by the mesh in the network, not in the app itself. And this is extremely powerful if you are like launching a new version of the app and you want to see how it behaves when there is a fault injected in the system. This is typically something that people do in chaos engineering use. So yeah, in a nutshell, Istio service mesh was designed initially to run inside Kubernetes, and it works very well inside Kubernetes. Something I didn't really talk about too much. You remember that sidecar we talked about that have to be added to each pod. So where you deploy your service, which is your app, and then you want that proxy to be running there. Istio has a built-in mechanism called Istio sidecar injection. And the way sidecar injection works is that you just need to put a label. Let's see. No, that's not what I want. You have to put a label on the namespace called Istio injection equal enabled, and then the sidecar will automatically be added for you, so you don't have to do it yourself. So you can keep writing your YAML or your Helm chart or whatever you're using the same way you're doing it today, and as the pod is being deployed, then the sidecar definition will be injected automatically for you. So this is something called Istio sidecar injection. All right. So yeah, in a nutshell, 4 main things that Istio can do, or service mesh in general can do. It can allow you to control the traffic. Well, it allows you to connect services to each other. It allows you to secure the service with MTLS and encryption. Allow you to control how the traffic gets managed. You can do more than what we saw. We saw just like canary deployment. We saw fault injection. We saw header-based mapping. You can do a lot of things. So if you're a developer, one thing you would care about is you would care about you can actually use Istio to do authorization and authentication outside of your app, right? So you can add a policy that as the request is coming in, it will check with an external IDP, IDP, like an identity platform. It will take the request, take the user, or take the token and verify if it's a valid token. And then if you want to add authorization, so authentication is one thing, using OAuth2, obviously. But if you want to add authorization, Istio itself has a plugin for Open Policy Agents. I don't know if you... Open Policy Agent is an open source project which does policy as code. So it allows you to run a policy engine to which you can send requests, and you say, user X want to execute operation Y. Is this thing authorized or not, right? And those authorization, you can just write them in the form of configuration files. So you can run Open Policy Agents inside your cluster, and then you can configure Istio to do the authentication and then send the request to the Open Policy Agent to do the authorization before it sends the request back to your app. So your app can be sure by the time the request comes in, it's already authorized and authenticated, so you don't have to handle all that stuff in the code. And I was talking with somebody earlier who's also a speaker. You can also do tracing. So you can just have Istio automatically generate spans and then trace each request. One more thing I didn't show, and I think I have a few minutes. It comes with like a super cool dashboard called Kiali. It's just an open source project. And if I would go here, I have like a built-in dashboard, but if I go to the graph, now the issue here, why this will not show, is I don't have enough traffic, but I can get traffic generated. Give me a second. Let's do this real quick. I just need this IP address here. What I miss? Yeah, thank you. And this shouldn't be here, or it should. Let's see. No. This shouldn't be here. Why is this here? Okay, cool. So it will generate a bunch of requests, and then eventually at some point, it will just build the graph for me, and the graph will have all the components, and it will tell me how much traffic goes between them. It will tell me if traffic is encrypted or not encrypted, etc. I am not going to wait for it. So let's... Oh, here we go. It's already there. So you see, it already tells me I have the products page. The products page is talking to the details service. The details service is talking to the reviews, which is talking to the rating. And it tells me which label, which version is currently active. And if I would have MTLS, which I don't, so the mutual TLS, it will have a little lock on top of the link. But if I go on the link, it can tell me it's HTTP. And I can already see a graph here of how many requests per second. I can see, I will be able to see numbers at the 25th, 50, 75, and 100 percentile. So basically, it's out of the box observability or monitoring. All right, so I guess let's see how much time do I still have. Still have 5 minutes. I actually want to leave time for questions at the end. I will leave you with this. In its current format, one of the biggest downside of Istio is the sidecars themselves. The sidecars add a bunch of complexity, but the most thing they add, or the major thing they add, is they consume more resources, right? Because they need CPU and memory. So I wrote an article which called, the title is not good. Actually, I did a talk based on the article called You Probably Don't Need a Service Mesh, which I gave to a bunch of people, and it's funny. Actually, I was invited by the Istio people to do the talk in front of the community. And I like to claim that I got them thinking about changing this architecture. So they are introducing a new architecture which doesn't have sidecars. This will take another 40 minutes to explain. So I will just leave you with this. If you want to Google what's the future of Istio, look for ambient mesh. And there is a bunch of articles that explains what this future architecture is going to look like. And with that, that's it for me. Thank you very much. I was learning how to say thank you in Greek, but I don't remember. It's Evcharisto? Evcharisto? Okay, Evcharisto. Thank you. All right. Any questions? We have 4 minutes. Yeah. Sure. Yeah.
Yeah, okay. I would like to ask you in the example that you saw us about the layer 7 routing that Istio can perform for you. If the original Kubernetes load balancer is bypassed, or this routing works on top of that, so that means the message comes, goes via the Kubernetes load balancer and then reaches a sidecar, and the sidecar performs the routing, or
yes. So
this is the case. Is this the case?
Yeah, the routing is done by the sidecar. Yes, correct.
Okay, so that means that the sidecar might get traffic for other pods. So it becomes, let's say, it might consume resources, and also you add one more hop to the routing with this way, right?
So
so there might be a disadvantage that you add more hops, and so you might have increased latency.
Yes, so that's another downside of the current architecture of Istio, is the fact that the sidecar adds this extra hop. It's actually not even one hop, it's two. Because if you have two services talking to each other, you have one proxy on the way out and one proxy on the way in. Istio itself is not really, it doesn't really add that much latency. I don't want to say bullshit, but there is a benchmark page. So for each new version of Istio, they run a benchmark for a fixed amount of traffic, and they can tell you exactly how much milliseconds of traffic, total latency will be added. It's not a lot. It's not great for low latency applications, because if you're doing a real-time low latency system, every half millisecond is extra traffic that you don't want. But for general purpose HTTP apps, it's not that much.
And one more question, if you support changing TLS certificates under traffic.
Yeah.
Under traffic with Istio, without traffic loss or anything.
Changing
the certificates.
It supports hot reloading TLS certificates without dropping traffic.
Okay, thanks.
Yes. Right. Any other questions? There was one in the back. Yeah. You need the microphone. I will not hear you from there.
Hello. First of all, thanks for your talk. Quick, silly question. When we have traditional pods, if something goes south, we just do port forwarding directly to pod, or we check the logs, or we check the IP tables if the service is correctly sending the traffic to pod. Now we have sidecars. So we have outgoing sidecar and the ingoing, let's say, sidecar. If something goes south, how do we easily debug what's going on? And if the problem is in the sidecar, or if it is in the pod, or somewhere in between. Thank you.
So you can still do port forwarding, right? Port forwarding still works. This is totally outside of the context of this talk, but there is one of my favorite ways of doing port forwarding in Kubernetes is a tool called telepresence. So when you have time, look it up. It's telepresence literally, and it's cool because with the kubectl, you can only do port forwarding toward one service at a time. With telepresence, you can just run telepresence connect, and it will generate port forwarding toward all the services in the cluster. So you can debug them on your laptop. But Istio has a command line called Istio analyze. So you can run the analyze command line, and it will canalize the configuration and see if there is misconfigurations, right? And then it has its own built-in tools for debugging, like Istio CTL, I think proxy status is another one. Proxy status with the dash in the middle. So this is an example of a thing that shows you if, for example, all the proxies are in sync with each other, if everything goes well. If you see something is unsynced, you can just like go and look at the logs of that specific thing. And then it has another feature which I don't have time to show. It has a feature where you can actually attach yourself to the sidecar, and then you can get copy of all the traffic. So you can like do like basically like you run a debugger inside the proxy itself, and then you can debug the proxy from there. So it does has a bunch of tools for debugging. There is actually, if you look up Istio debugging, there is a page that explains all the debugging steps. But yes, it does add complexity. That's the downside. No worries. Any other questions? Yes, there is one question over there.
Okay, thanks for the presentation, first of all, and my name is Pavel, and I have one question. So basically, if we are in a company already have microservices, and of course we are aware of this idea of service mesh, like what can be the red flag for us for moving to the service mesh? Like, what are the limitations we have to consider at the very beginning? Because obviously there's like a little bit new approach with what people get used to already. And is there anything we have to consider?
So if you go look that article I mentioned that I wrote, or just type my name, and you probably don't need a service mesh, you will find the article. I go in details about all the considerations. So there are a lot of things. There is like the added resources that you have to pay for. There is the added latency, which we talked about. There is the added complexity for debugging, obviously. My best advice is to benchmark it. Just like take your existing system. The good thing with Istio specifically is that you don't have to go full in, right? If you have already a system running, you can deploy Istio and you can onboard namespaces, one namespace at a time. You can add it to the mesh, and it has like a compatibility mode where it can, if the service have a sidecar, it will use the sidecar for talking. If it doesn't, it bypasses the sidecar. So if you are in the middle of this migration process, it will support running both modes, with and without sidecar, right? So the best advice would be to benchmark. Just deploy it, try one namespace, see if it works, and then collect some metrics, and then based on that, you can roll it up. Right? I guess we're out of time, so I'll be around if you have more questions. Thank you very much.